Sydnium. Sydney runs an advanced materials engineering lab. She has created a new superconductor using the elements barium, copper, mercury, oxygen, and calcium, which she has named Sydnium. Sydnium has a density of 1.65 grams per centimeter cubed. Sydnium is a very expensive compound. Sydney's lab charges $1,728.50 to produce 1 kilogram of sydnium. Sydney has received an order for a solid cone of sydnium. The order stipulates that the cone must have a lateral surface area of 450 pi centimeters squared, and that the slant height of the cone must be 11 centimeters longer than twice the length of the radius. How much should Sydney's lab charge for the cone of sydnium? We have to figure out the radius and the slant height, and we're told that the lateral surface area is 450 pi centimeters squared. So the lateral surface area of a cone is perimeter of the base times the slant height divided by 2. The lateral surface area is 450 pi. The perimeter of the base is going to be the circumference of the circular base, which is 2 pi r. The slant height, we're told, is 11 centimeters longer than twice the length of the radius, so 2r plus 11. I'm going to cancel the 2's. It's going to give me 450 pi is equal to pi times the radius times 2r plus 11, and I've noticed I have a pi on both sides. If I divide both sides by pi, we end up getting 450 is equal to the radius times 2r plus 11. The radius comes in, multiplies the 2r, and multiplies the 11. Distributive law. So we have 450 is equal to 2r squared plus 11r. If I subtract 450 from both sides, we end up with the quadratic. 0 is equal to 2r squared plus 11r minus 450. This is a nice trinomial. We want to solve for r, so we're going to use our quadratic equation. Once again, I'm using Mariana's quadratic equation. The a value is 2, the b value is 11, and the c value is negative 450, and calculate. We get negative 18 centimeters, which doesn't make sense for a radius to be negative, or 12.5. So I'm going to take the 12.5. So the radius is 12.5 centimeters. The volume of a cone is area of the base times the height divided by 3. We can figure out the area of the base, but we're going to have to do some work to figure out the height. We're going to have to use Pythagorean theorem. We have pi r squared times the height divided by 3, but we don't have the height. Here's this triangle, just redrawn over here. So the radius is 12.5, and 12.5 plus 11 is the slant height, remember. So 12.5 plus 11 is 23.5. I'm going to use my Pythagorean theorem, and I'm going to call this side A, this other leg B, and the hypotenuse is always C. So we have B squared is equal to C squared take away A squared, which is 23.5 squared take away 12.5 squared, which gives us 396. So b squared is 396. Take the square root. That gives us b is equal to 19.89975. So that's the height here. Now we can find the volume. So pi times the radius, which is 12.5, all squared, times the height, which is 19.89975, divide by 3, which is 3,256.08877 centimeters cubed. This is the volume. And we're charging this amount to produce a kilogram, so we need to know the mass. So we're going to have to go to our density formula. If we had 1.65 grams per 1 centimeter cubed, and we know how many centimeters cubed we have, so we can set up a proportion. So that's how many grams do we have out of the 3,256.08877 centimeters cubed. To get the x alone, I'm going to cross multiply that. So we end up with 1.65 divided by 1 is 1.65. So 1.65 times the 3,256.08877 is equal to x. 5,372.54648 grams. To convert grams to kilograms, I'm going to divide by 1,000. You can use your King Henry died, Larry didn't curse much. You're converting grams to kilograms, which means you're moving 1, 2, 3 steps on the diagram. 1,000 grams is a kilogram. You could also use that knowledge. In any case, you end up with 5.3725 kilograms. Each kilogram is worth that much. So I'm going to multiply the 5.3725 times the 1,728.50.5, or I could use a proportion. This is the cost per 1 kilogram. Cost per 1 kilogram is equal to what cost? How much? Out of 5.3725 kilograms. Cross multiply, and so you end up multiplying the kilograms times that value anyway, which gives us $9,286,446.59. So Sydney's lab needs to charge $9,286,446.59. And that's it for question number 12. Have a good day.